So this problem is asking us to find the distance between two ordered pairs, and a lot of people have the knee-jerk reaction of saying, distance formula, here's this fancy formula, d equals square root of parentheses x2 minus x1 squared plus parentheses y2 minus y1 squared. Happy, happy, if I just plug everything into there, that's great. Yeah, but what if you memorize it incorrectly? What if you make a sign mistake in playing around with that? My claim is that you do not need to memorize the distance formula because the distance formula is nothing more than a cheap ripoff of the Pythagorean theorem. When you're asked to find the distance between 2 points, just draw a picture. So in this particular case, let's draw a picture of what's going on here. We have negative 3, 1. So that's right about there. We have 2, negative 1. That's right about there. Now, with this being a multiple choice test, you can do even less work than the Pythagorean theorem. You can basically just count. You can count roughly how many units it takes to get from there to there. You can say it looks like it's about 1, 2, 3, 4, 5 and change. So it looks like about 5 and change if we're just sort of putting tick marks about how far one unit is. So it's definitely not 1. It's definitely more than 1. Well, what's the square root of 5? Well, the square root of 5 is somewhere between 2 and 3 because we know that the square root of 4 is 2 and we know the square root of 9 is 3. So square root of 5 is somewhere between 2 and 3. That can't be the right answer because we know it's about 5 point something. Well, square root of 7 is also between 2 and 3 for the same reason. So it looks like our answer is D because this is somewhere between 5 and 6. Because 5 is the square root of 25, 6 is the square root of 36, 29 is somewhere in between those two. So the fact that this is somewhere between 5 and 6 tells me that's the right answer. I can get that and be very sure of that answer just by looking at the picture. Whereas if I use the distance formula, I don't know if I made a mistake, if I put a plus where I should have put a minus or vice versa. This is very good to be able to look at it and say, this is it. And this is not cheating the system. Math is all about problem solving to say, what are the tools at your disposal? Apply those tools and get an answer. And so in this case, our tools are visualize it. And that is a tool you should always use in math. Visualize your situation, draw a picture, see what's going on, try to understand it. Because that's the goal of math. Math is not about learning formulas and applying formulas. It's about solving problems and learning problem solving techniques that can be applied in any field, not just math. Now, going back to this actual problem, if we want to continue through with this one and actually do the Pythagorean theorem, we're going to introduce a third point into the mix over here, which we get by just drawing a line straight down and drawing a line straight over. So this allows us to form a right triangle where we could actually find this distance. But now again, counting comes into play because that vertical line that I drew, instead of doing any sort of math of doing 1 minus negative 1, we just count and say, how many tick marks are there? Oh, there's 2. And same thing for the horizontal line. We can just count. We can say 1, 2, 3, 4, 5. It's 5 units over. So really what's going on here is we have nothing more than a simple right triangle where we're going to use the Pythagorean theorem and say 2 squared plus 5 squared equals d squared. So 5 plus 25 is d squared. 29 is d squared. D is the square root of 29. So again, it's not terribly hard to do the actual math if we do the Pythagorean theorem, but it sure was a whole lot easier to just count.